Good evening, ladies and gentlemen. I want to get started, but before I get started on today's event, I want to say something about the conversation series that we've been running for about a year now. Our first series was with Troy Wade. It was on nuclear Nevada. So we talked about a local issue that creating bombs and exploding them and using them for different types of purposes that we all know about. The main idea of the conversation series is to make audience participate with the speakers. I don't like PowerPoint presentation. Actually, I never make a PowerPoint presentation in my class. I like the active participation. That's how we really learn well. So as part of the series, we have the second program. It's Archangel, the CIA Supersonic A-12 Reconnaissance aircraft. And when I read up on it, I didn't know much about it, and I read up on it on the web. It looks like it's a major milestone in the history of aeronautical engineering, the way I see it as an engineer. And I saw that they were trying to come up with new materials, especially titanium-based materials. They were trying to reduce the radar cross-section so that they can go undetected. That was an interesting idea. This is actually brought to you in collaboration with the UNLV's College of Liberal Arts History Department, the Nevada Aerospace Hall of Fame, and through the generous support of our community partners, Tronox and Timet. I'm honored to welcome the Chief Historian of Central Intelligence Agency, Dr. David Robarge. Dr. David Robarge is actually right there. And he received his PhD in American history from Columbia University. After teaching at Columbia and working at Gannett Center for Media Studies at Columbia, he joined CIA in 1989 and became a political and leadership analyst on Middle East. Dr. Robarge joined CIA history staff in 1996, and he was appointed Chief Historian of the CIA in 2005. He has published a classified biography of Director of Central Intelligence Agency, John McCone, and unclassified monographs on CIA's Supersonic A-12 Reconnaissance aircraft and intelligence in American Revolution. His articles and book reviews on CIA's counterintelligence, covert action, and technical collections have appeared in Studies in Intelligence, Intelligence and National Security, and the Journal of Intelligence History. He has taught intelligence history at George Mason University in Virginia. He has also written biography of Chief Justice John Marshall. At this time, I invite Dr. Robarge to the stage.
Thank you very much for that warm welcome, and it's a pleasure to be here. I've only been in Nevada one other time before this. It's very much a pleasure to be back and to see this lovely campus, and we hope tonight to present to you some fascinating insights into a technologically marvelous program that the agency and the Lockheed Corporation and the Air Force all work together on to provide key intelligence answers to some very pressing questions during the Cold War. And tonight you'll be hearing from three participants in that program. We have Frank Murray on my immediate left here, who was a pilot on the A-12 and flew 4 of the 29 missions that the aircraft was involved in. In the center there is Thornton T.D. Barnes, a former CIA Special Projects engineer and technician who worked on some amazing projects related to radar and electronic countermeasures and electronic countermeasures. And on the far end there is Roger Andersen, former Air Force officer, CIA ops officer and support pilot, who performed some essential roles out at Area 51 in support of the program. What I'm going to do for a relatively brief period of time is skim through the highlights of the program and try to lay out for you why it started, what it was intended to accomplish, the major technical obstacles it had to overcome in order to become operational, and then a little bit about what it did during its relatively short life as a program, less than 1 year. But I want you to keep in mind that the A-12's development and missions laid the groundwork for the much longer and better known SR-71 program of the Air Forces. Between the two aircraft, you had 20 years of active service, over 20 years of active service, over 3,600 missions flown in lots of hostile areas around the world. Not a single one of them was shot down, and major intelligence was gained in some very, very crucial hotspot situations. So let's talk quickly about this amazing aircraft, the A-12. We call it the Supersonic Sky Spy. The name Archangel comes from the fact that it was the successor to the U-2. Very soon after the U-2 was designed and deployed, everybody knew eventually it would become a target. And indeed, in May of 1960, it was a target when the Gary Powers mission over the Soviet Union ended abruptly when the aircraft was shot down. But even before then, engineers and program managers at Lockheed and at the CIA were thinking about a successor to this aircraft that would be a complete generation ahead, or several generations ahead. One that would fly so high and so fast that it would be essentially invulnerable to enemy attack. The program took birth in August of 1959, and as you can see here, it was a kind of a hard slog, and we'll present to you in a little bit the reasons why that it was so technically challenging. You don't have for 3 years the first test flight. It takes another year or more after that to get up to the operational speed. I want to underscore the fact that this aircraft flies at above Mach 3. Its recorded fastest speed is Mach 3.29. This is faster than a rifle bullet, and it will do this for an hour straight. This is amazing. And on top of that, you have the fact that beyond that, it is an intelligence collection platform. It's there to take photography, and there you're getting imagery with 1-foot resolution from 85,000 feet. Operationally, it is not deployed until May of 1967. Though it was intended to overfly the Soviet Union, it was never used for that purpose because after the Powers shoot down, aerial overflights of the Soviet Union were simply politically unfeasible, and you had satellites collecting most of the necessary intelligence behind the Iron Curtain. So what are we going to use this amazing aircraft for? Well, the Vietnam War is heating up, and so it is deployed over there to fly 26 missions in Southeast Asia, and then after the Pueblo incident in January of 1968, 3 missions over North Korea to help find the Pueblo and to keep track of any potential North Korean hostilities that may be developing. At the same time, the SR-71, the slightly different Air Force variant, is deployed, running the same missions. You now have 2 programs doing the same thing. It's a very costly program. The Air Force tends to kind of muscle the agency out of things various times in our history, and that's kind of what happened. The SR-71 sort of won the operational and political and budget battle, and the A-12 is decommissioned after barely 1 year of service. But as I say, it became the groundwork for the SR-71 program. From an engineering standpoint, these are the key challenges here. How do you get an aircraft to fly that fast for that long at that height? Mach 3 minimum, 80,000 feet minimum, and to do so for an hour at a time between various refuelings, because this is a gas guzzler. 22,000 pounds of fuel consumed per hour by these amazingly powerful engines. We'll see them in a minute. And also you want to have something that is has such a small radar cross-section that even if it's painted, it's almost undetectable. And indeed, despite the fact that there had to be some compromises made on this aspect of the design requirements, the aircraft was a very small image. Much of this has to do with the brilliance and management skills of Clarence Kelly Johnson, America's premier aeronautical engineer with a whole slew of aviation achievements behind him. Amazing aircraft that he was responsible for. And he's really the one who put this idea from paper to operational use. Now there's a competition with a competing design by Convair Corporation, an aircraft that seemed better on paper but was simply technologically unfeasible. In contrast, the Archangel is able to, as they develop it in the wind tunnel tests and elsewhere provisionally, is able to meet those engineering requirements. You can see quickly here how the design changed during the development phase. And it's very striking, the different types of test designs that were used, the wind tunnel models and such. Eventually you wind it up turning into this kind of Cobra-like looking aircraft with a very sleek design, the distinctive bat wing shape, the dart nose, all of these things for aeronautical purposes to promote streamlining and to reduce radar cross-section and provide lift at a very thin atmosphere of 80,000 feet plus. Along the way, imagine you engineering students here having to deal with these kinds of challenges. First, you can't use conventional aviation materials. In effect, you developed a cottage industry around the design and construction of the A-12 because almost everything had to be redone. You had to use titanium for the aircraft skin because that was the substance that could withstand the very, very high temperatures. It's a very neat little insight into the program that we got the titanium for the construction from the Soviet Union because the American supply was of inferior grade. So the CIA built a front company apparatus to covertly acquire the titanium from the very people who were going to use it to spy. It's a nice little piece of that story that I'm very happy I can say now in public. Also, the challenge of the heat. Lubricants, wiring, special tires, everything had to be done with that in mind because the cockpit would get 400 degrees, the skin of the aircraft would go anywhere from 500 to 800 and of course much higher around the edges. The special camera window had to be developed because if you can't take good pictures out of this because the heat is warping the glass, then what use is it? Corning came up with a fascinating fix on that. The pilots, and Frank Murray will be able to talk to you about this, they wore a special pressure suit. They lived in a very enclosed environment. There was no insulation in there to cut weight. You could burn your hand on the windshield if you touched it. The fuel inside the aircraft was one of the oddest things about it. One, it served as a coolant. If you look at a schematic of the aircraft, most of it is a gas tank, a fuel tank. And this fuel inside the aircraft is serving as a coolant. But it is an odd fuel because it has a very high flash point. Conventional aviation fuels would just blow up at these temperatures. So you had Shell Oil developing a special fuel, went by a couple of names, but had such a high flash point that you could throw a match into an open barrel of it and it would just extinguish immediately. Consequently, it had to have a special chemical igniter in order to flash and get working. It also corroded fuel tank sealants, which is why the aircraft would sit in the hangars or on the tarmac, drip, drip, drip. In fact, Kelly Johnson and his staff calculated the acceptable drip rates from various parts of the aircraft, and they would deploy barrels and trays and pans and catch the fuel, dump it back in the storage container, and use it again. The tools used on the design were special. They had to be special chemical composition because conventional tools would leave residues that would cause bolts to snap off at high temperatures. It would leave etchings in the skin. And so the old toolkit literally had to be disposed of and new fabrication tools made. The whole aircraft was handmade. No assembly line procedures. Everything done like a Rolls-Royce in effect. The engines served to be one of the biggest obstacles to success in the program because Pratt & Whitney had a real challenge getting an engine to run so hard to produce that kind of lift and speed. It also had the kind of daunting characteristic of flaming out at high speeds, which would cause a pretty horrific bucking inside the cockpit. And again, pilot Frank Murray can discuss that with you. The radar cross-section. Here you have a full version of the A-12 inverted and up on a pylon that comes out of the ground just like a hydraulic lift in a gas station. And this was used, as T.D. Barnes will talk about in a little bit, for radar cross-section design modeling. It's a fascinating story about how we did it, what we were looking for, and the achievements made not only in this, but also in some spin-off programs as well. I'd mentioned the engines. Immensely powerful. Each engine had the thrust of an entire engine room of an ocean liner. So think of the Queen Mary back then, the engine room of it, one of those hanging off each wing of the aircraft. And this will give you a sense of the amazing power. And no surprise, kind of hard to start. They would wheel out big block V8 racing engines, crank them underneath, get the blades on the turbo ram going, throw in the fuel, spark it with the chemical igniter, boom, and you were ready to go. Meanwhile, as it's taxiing out the runway, it's sucking up everything off the surface like a big vacuum cleaner, which would cause some engine damage in some of the early attempts. So before any of these was rolled out, you had a crew going out there sweeping and brushing and picking up debris and making sure it was as smooth a run as you could possibly get. A good look inside the Skunk Works here, showing you the very individualized design and fabrication of the aircraft. Shipping it to the test facility, we can now say Area 51 in public. That has now been acknowledged, instead of the Nevada test site or various other euphemisms. Some interesting stories surrounding the transport of the aircraft out there, and not the least of which is the close brush but with a Greyhound bus that was careening around a curve and got a little too close to the big crate. The security detail immediately waved it over to the side. There was a quick chat on the side of the road. Some money was passed and some declarations were made that this never happened, and everyone went on their merry way. First test flight, April 1962, and eventually you had 15 of the aircraft built. There was a trainer version you can see there with the two-man cockpit. The standard A-12, had one operator, one crew, a pilot, and a camera bay. The big difference between it and the SR-71 is the SR-71 carries two people. There's a systems officer because it has several sensing systems in the nose. And there were also some of these used for training, some of these used for operational design improvements, and a handful of them were designed strictly for operational use. I'll give you a quick look at the marvelous design innovations here. We have one of these at CIA headquarters now that we acquired a few years ago when the program's cover was lifted. It really is an amazing and beautiful aircraft. They even tried a camouflage design on it, but that didn't take. Here we are with the pilots. Their own design specifications. They had to be a certain type of person, they had to look a certain way, they had to fit in the cockpit. They were all, as we call it, sheep-dipped from Air Force to CIA employee, and 14 of them were eventually chosen. 2 of them tragically killed during the course of the program, along with 2 other pilots who were engaged in support roles. Here's the cockpit that people like Frank Murray had to squeeze into. An interesting sort of retro look, if you will, because Kelly Johnson was very keen on the tried and true. He was resistant, for example, to putting complicated electronics on the aircraft because he didn't trust them. He kind of liked the old analog versions of things from the previous aircraft. But one of the things that helped solve the engine's unstart problem was those nose spikes. You probably saw them sticking out of the engines. Those would retract as much as 2 feet during the course of a mission. They're a flow regulator to make sure that the combustion is working okay back in the engine. If it's not, it snuffs out. But you couldn't get that to move quickly enough with a standard hydraulic system. So Kelly had to install electronics, and that took care of most of the unstart problem. The fuel tank question, and I hope Roger will talk about this. The huge amounts of fuel that this consumed meant that you had to have an amazingly complicated logistical infrastructure to support this. Fuel tank depots and refueling tanks and support crew at various locations around the world in anticipation of a more global mission. Eventually, this is all consolidated out in Kadena. I'm not going to get into the A-12 variants here to any degree. There was a drone program in which you'd have a drone that flew even faster being launched from the A-12. That program didn't work, whether we were doing it or the Air Force when it took it over. Here you get a good sense of the variety of the aircraft in the program. There was a fighter interceptor called the YF-12, which only 3 of which were built, and they were never deployed. They were intended to shoot down incoming Soviet long-range bombers, but that was taken over by the F-111. The only time that these appeared in popular culture was a YF-12 shooting down a flying saucer that's no doubt circling over Area 51, I imagine. But here's a nice shot, and it's the only place in the world you'll see the 2 aircraft side by side, Palmdale, California. And here you get a very good sense, I think, of the design differences between the SR-71 on the left, and that's the one you'll see, for example, at Udvar Hazy Air and Space Annex out in Washington, and comparative characteristics. Talk quickly about the missions. Eventually it was used only over East Asia, the Black Shield program. 29 missions, 26 over Indochina, all of them successful. Only one of them was unsuccessful in the sense that it went out to do its mission and didn't bring back any useful photography because of cloud cover. In another mission, the camera failed halfway through, but at least you got half of the mission done. A typical route, flying out of Kadena Air Base, refueling over Thailand, running a mission, going back for refueling if it was a dual pass, going back to Kadena, dumping the fuel, and landing. These neat maps were taken directly from agency files. This is old school cartography. Nobody's sitting here with a computer doing these. It's a piece of mylar with ink pens and little tape and stick-on decals and calligraphy sets, kind of the way maps ought to be made from a historian standpoint. They're just kind of fun to dig out of the files. The very first mission, Mach 3.1, 80,000 feet, 3.5 hours time. It only took 20 minutes to get in and out of enemy territory. This is one reason why the aircraft was so successful. By the time anybody noticed it, it was gone. You couldn't track these effectively. Even if you did, you couldn't do anything to them. You had to fire miles ahead of them to have any hopes of hitting them. They had spoofing devices, electronic countermeasures on them, and they took pictures like this, 1-foot resolution. This is great stuff. What did we learn from it? They didn't have surface-to-surface missiles, so they were going to start firing into South Vietnam. We could track military movements. We could do bomb damage assessments. We could find the SAM sites to protect our pilots. All sorts of people are alive today because of the accomplishments of the A-12 mission. North Korea, a very important scenario. Unexpectedly, January '68, a Sigyn ship run by the Navy for NSA is captured. The North Koreans won't admit they've done anything. We catch them in a lie by overflying North Korea and finding it there in Wonsan Harbor. The photo interpreters did a great job in tracking down where this aircraft was. Suddenly, diplomacy could work. The North Koreans are caught in a lie, and after 11 months of pretty nasty negotiations, the remaining crew is released. Some died in captivity. The ship is still over there, though, as a propaganda trophy. The last mission, 6 May 1968, also over North Korea. Decommissioning. The budget crisis, the bureaucratic battle, do you need an overt mission or a covert mission to do an overt missions job, and the program is put out of business. What do we have as sort of the legacy? In aeronautical engineering terms, still the highest flying, fastest piloted jet aircraft ever made. And you have to have all those qualifiers in there to make the point. We're not talking about the X-15. We're not talking about something that can't take off and land on its own. We're not talking about a drone. We're not talking about something dropped from the wing of an airplane. This is a true piece of aviation engineering. And I've mentioned the key intelligence, and the legacy lives on in the stealth technology and some of the other advancements made during that time. And here's the A-12 that we have now at CIA headquarters. The first operationally outfitted one to fly at Mach 3, the 8th one in the series. Now, I'll turn it over to my speakers here tonight to talk about briefly their own experiences, and then we'll engage the audience in a Q&A. We want to make this conversational. I hope I've laid out enough of the basic stuff of the program so you have a good sense of what they'll be talking about. Frank, how about if you chat a bit about what it was like to fly the aircraft, and maybe some reflections on any of the 4 missions that you flew. Use that one.
Which one?
Yeah, okay. Thanks.
Pilots always need help. You know what they say about pilots? The 3 most useful things to a pilot? Useless, bad word, useless things to a pilot is a runway behind you, the altitude above you, and a navigator. Sorry, Roger. You got to start with something light. The A-12 airplane was, at the time it was built and flying, was the fastest thing around, of course. And there's still nothing as fast as that airplane that breathes air in its engines. You got to get a rocket to go faster than that. Cruising at about 33 miles a minute. About 3,400 feet per second, much faster than a 30-06 bullet comes out of the barrel. For that reason, it gets hot. It gets hotter than hell. The sticky points on the airplane, pointy parts, curves, intersection of the windshield with the fuselage, things like that are what I call the sticky points for heat. And the temperature rise in those areas is a couple hundred degrees more than across the flat skin. The airplane temperature, just for drill, at the windshield base was 650 degrees. The temperature at the rudder base was 1,050. The reason it was so hot back there, the engine was heating the skin from the inside and friction was heating it from the outside. So when they put the probes on it in the test, they found out it was 1050. That's the hottest spot on the airplane. But basically, Bob Gilliland, an old test pilot for Lockheed and flew lots of airplanes, also flew A-12s, he called it about an 800-degree average airplane. Well, that 800 degrees tells you you can't use solder in wiring electrical systems because it'll melt the solder. So they had to come up with, along with other inventions, they had to come up with cinch connectors and things like that to make mechanical connections instead of solder connections, which were common in cannon plugs and things like that. I've always said that the airplane, as far as I was concerned, was nothing unexpected in my view as a pilot. I've been flying airplanes that were 1.7. I flew a lot of 101 Voodoo, and it's a 1.7 Mach airplane. It's no true slouch. But Mach, it never got hot. And, you know, you could put your hand on the windshield anytime you wanted, at any speed, and it never felt any heat. And there wasn't any real heat rise. The A-12, you dare not do that unless you want to leave your gloves stuck to the windshield, because it'll melt them. The windshield's 650, so it's pretty hot. But the airplane to fly was a basically simple, straightforward airplane until Dr. Robarge mentioned a little bit about it. For lack of a better term, they called the inlet failure an unstart. It's called unstart because something had to start it, and there was actions to make the inlet start working as a recovery duct. And if that geometry got out of whack and the bypass doors didn't work right or something like that, and you tried to stick 6 pounds of air in a 4-pound bag, the engine, it's going to barf. And when it does, the compressor stalls, and now you lead into what's called the full-blown unstart. That was the only really bad thing about the airplane as far as I could see. It flew very easily in most regimes, even at very high speed. It wasn't much any difficulty in flying the thing. As you got light on fuel, and you typically would, it was carrying 10,000 gallons of fuel. When you got down to, you know, maybe 1,000 gallons of fuel remaining, the airplane was pretty light, and it flew very nicely. And like he said, we would cruise at mission altitudes up to 85, 86,000 feet were not uncommon. We flew a whole lot of them a little bit lower than that because it was just a little more comfortable. But the airplane was extremely easy to land, probably the easiest airplane I've ever flown, jet airplane, to land, because it was a big lifting body. And even at light weights for landing, the thing would float. It would float and float, so you had to plan on it. There was no speed brakes on the airplane, so you did your planning to land about 10 miles out, not over the end of the threshold. But it was a relatively easy, very easy airplane to land. Takeoff was nothing magnificent either. We couldn't take the airplane off full of fuel because the tires would all blow out as you rotated for takeoff. Now that's not a good way to go. You're going to blow out 6 main wheel tires on rotation. That's because on a delta wing, as you know, when you bring the elevons up to raise the nose to lift off, you load the main gear. You push down on the main gear tires. They're already turning typical takeoff 215 knots. That's 260 miles an hour to take off. And as you push down on the tires, which already got hot on the roll, they'll bust every time. So that's why we took off with half fuel always, and we went to a tanker and topped it up. The top-off tanker was a standard thing you had to do. Normally did that within 100 miles of the base, and then you went about where you're going. Then at the end of that leg or legs, whatever, you'd refuel with another pre-positioned tanker and get on with it. The airplane only carried one camera, one big main camera. The one we used most was the most reliable and the best performer, and it was made by Perkin-Elmer Company, and a small company still on the New York Stock Exchange somehow, but they make superior optics. Kodak made the backup camera, and Hikon made the tertiary system. And Hikon was a very complicated system, not very reliable, but it was a hell of a performer when it worked. But you see the shame in flying 10,000 miles to get a picture of somebody in the outhouse, and the camera broke. So we stuck with Perkin-Elmer. Kodak probably would have been about as good. It was basically the same design. Anyway, that's about the mission in a nutshell for that airplane. If anybody has a question about that, I'll entertain that now.
Was it tricky flying slow enough to refuel?
No, refueling that airplane's a piece of cake, mainly because the airplane has got a redundant 3-channel SAS, stability augmentation system, sort of a full-time autopilot. And refueling is basically just a formation game. You just fly formation with the butt end of the tanker, and the boomer takes care of the refueling. You open the door, he sticks the boom in there and pumps gas. Roger used to pass a lot of gas because he was a tanker pilot before he came out to the 1129th. But anyway, we didn't refuel off his class of tankers. We refueled off the 135, which is basically a Boeing 707 tanker. It's an easy airplane to refuel, it really is. Until you get full, then you run out of power, and the tanker's getting lighter, and he's flying better, and you're getting fatter than a goat, and you can barely hang on. But you get it down and leave, and that's it.
Is there any particular flight conditions where the unstarts were more prevalent?
Yeah, there was a place where they had every unstart I think that I ever heard of or witnessed, and I've had enough of them, mainly happened between 2.2 and 2.4 or 2.5 Mach number on the acceleration. And the reason they happened there was you were in the area, in that flight realm, where you had the maximum available thrust from the engines. The inlet was really working. The engines thought they were below sea level as far as airflow control was. They were getting all the air they could stand and more. and any mismanagement, auto or manual, of the bypass door system or spike position, and she'd unstart. I had one unstart that broke my helmet. I got beat to the side of the canopy, which is only, the canopy's only about that wide, so it's not a long travel for the hat to hit, and it broke the sun visor off. Well, it broke one side of it and was hanging down like this. So I snapped it off and stuffed it in the mat box, and after I dried my pants, I came home. That was the worst I had. I have a number of those, but that was the worst, and that's where they happened. On the Axel, full bore, 2.3, 2.4, 2.5, right there. And at that speed, you would be, the indicated airspeed at that point would be 450 knots equivalent. And the Mach number I said, and the altitude would be 65,000 or so climbing. Initial level off was 75,000. That's the point at which the cruise climb reached 3.2 Mach number, and at that point you throttle back, level off, and cruise climb from there on.
Let's take one more for Mr. Murray, and then we'll have TD get up and...
You said that the aircraft traveled at really high speeds and it got really, really hot. When you guys landed, how long do you have to wait for the engine to cool down?
The heavy parts of the airplane stay hot long after you land, like the main gear struts and parts like that that were heavy metal. The skin cooled off rapidly. The skin, you'd get down, the skin wasn't warm to the touch at all. But don't touch those main gear struts or the nose gear strut. And those things are made of solid titanium, and they got hot. That's the hottest part on the airplane after landing. That's why they put cooling fans on the thing to cool the brakes down and things like that after landing also.
Thank you. Good. Thanks, Frank.
I might mention that this was an era before computers. We all carried slide rules. This plane was built with a slide rule. We didn't have computers. And it's still the fastest flying, the highest flying in the world, and probably never will be, that will never be overtaken because they won't build planes like that anymore. We don't need them, manned planes. The radar end of it was a challenge, even as they were designing the plane. Those of us in the radar field our first challenge was determining whether or not the Soviet Union was going to be able to track this plane and shoot it down. That was we're building a plane to fly over Russia, but can we? And I happened to be in a position, I was in the Army. I was trained on every surface air missile known to man at that time. It was very early in the industry, and we were still learning the ECM, ECCM, that's your jamming, anti-jamming of the planes. And the CIA was trying to determine the capabilities of the Soviet radar. And conveniently, they had moved into Cuba at that time. That's long before we realized the missiles were there. And this gave the CIA and my department, both, I started out as Army Intelligence and before I got into electronics, but gave us a testing ground close to home, 90 miles from the coast of Florida, to evaluate what the Soviets had. And they had pretty well the best stuff they had there, but they had this tall king radar that was just scaring us to death. We didn't know what it could do. And we had a fellow with the CIA named Joe Poteet. He was the head of the program that we were doing. We had a ghost plane, we had submarines, we had all the assets needed to evaluate the Soviet radars, and we were concentrating on those in Cuba at that time. But on the talking, I'll tell you a story of how technical some of our activity was. Gene realized that we were getting reflections off the ICBMs that Russia was testing in the Soviet Union off the Tall King radar. They were using it, and that gave them the bright idea that maybe we can get a reflection off the moon. And we put some huge antennas, or Gene and his group did, off the New Jersey Turnpike, shot them, aimed them at the moon. In 30 days or so, they knew the location of every radar in Russia, just with reflections off the moon. So that's the level of some of the tech that we were doing, and I was in the business of trying to learn out what the ECM capabilities of the Soviet missiles, their planes were, so that our missiles could get through and bring them down. And we decided, since I was working with the CIA, they had one of their ghost planes parked at Biggs Air Force Base right outside of Fort Bliss, where I was stationed at the time with the Hawk missile unit. And we decided, well, let's test the Hawk against the ECM of the planes. We just loaded one up in the belly of a plane out at Biggs and took off towards Cuba. And we got close to the island, and when the plane started taking off to intercept us, we illuminated the island as though we had locked onto them to induce them to turn on their jamming and to see if our missile could get through it. And I'm sitting there tweaking on a missile, watching this antenna to see when it lost interest in the planes. And I was actually the eyes of a missile that thought it was in flight. It really thought it was flying. And of course, we scrambled a couple of 101s out of Homestead to intercept the MiGs that was headed our way to do us harm, because they really couldn't take a joke. And but we got what we needed. We learned out what their ECM was, and we designed our surface-to-air missiles around that. And I'll guarantee you, if it had been us shooting at Gary Powers or anyone else, would brought them down. We were that far advanced in our SAM technology over the Soviet Union. But this was this was in the early stages, and what we determined was we could not safely fly over the Soviet Union with anything. And we never did again, except with satellites. But anyway, to make a long story short, I ended up eventually being out at Area 51 towards the end of the program. I was on the NASA high range tracking the X-15, XB-70, the YF-12, the A-12, just about anything we had test flying for the B-70. We were trying to develop a Mach 3 plane in several different roles. We had the Mach 3 bomber that we were developing. We had the A-12, which was the very first one, and then we had the YF-12, which was just an A-12 that we put took a camera out of and put a man in there, and we hung missiles on it to have a Mach 3 interceptor where we could meet the Soviet bombers before they could even get out of Soviet airspace if they came at us. And then we had the SR-71 that followed after all of this, or just about parallel. We were ahead of it in all respects. But they brought me out to the area towards the end of the program. Basically, we were wanting to do some Mach 3 radar cross-section as the plane was coming in from a sortie. We flew 2,850 missions out of Groom Lake with the A-12. And of course, it didn't officially exist, and this accounted for a lot of UFO sightings at the time. We would leave a very heavy sonic boom, and thank goodness for the Navy at Fallon, they took the blame. They didn't know what to take the blame for, but we did not exist, and they covered for us. And we had a cover story for everything. We crashed a few. One of them crashed but went over. It became a F-101 with a nuclear bomb aboard. That's what kept the public out. And each one had crashed. It became something else, even the SR-71. But anyway, I got in on the tail end of the program on that part of it, but mainly I was focused into stealth. The A-12, a lot of people never realize it, but it was our first stealth plane. Most people think it was the Have Blue prototype that later became the F-117. But we brought in my Nike radar from Fort Bliss, so we would have air defense missiles radar to look at it, our acquisition radars. We had virtually every radar known to man out there before it was over. But the big coup that we got during the Six-Day War, Israel captured several MiG planes and a lot of Soviet radar. And we ended up with both out at Area 51. We were evaluating the MiGs under the project Half Donut, Half Drill, Half Ferry, and that's another story in itself. But that's one of the things we were doing was determining what did they have in that way, and that's one of the projects I was honored to be on. But mainly, we wanted to know, when we were looking at that mock-up that you saw, we looked at it for 18 months. Just tuning it up, changing this, changing that, because you get a reflection and this is not going to work, and they change it, and we look at it again. For 18 months we looked at it. We finally got it down where it was the initiating radar was not seeing it. But we knew that we were merely reflecting the signal somewhere, and we didn't know where. We need to find out, and we need to know what will pick it up, the reflected signals. And we needed to know what the Soviet Union sees, so what we did was got our hands on these Soviet radars. That was one of my jobs, was get those things working. We scattered them all out in the desert out there, and when we looked at the A-12, we'd have them on there trying to pick up the reflections that were coming off of it, and because that was just as good as the primary radar having the track, because all they had to do was correlate it back into a database, and you knew exactly where it was at. So that's some of the early things we was doing with stealth, and even with the MiGs, we put them on the pole. Everything we get, anytime they parked one of their planes and left it unattended, we ended up putting it on the pole and looking at it with the radar. And the MiGs and of course, the A-12, we eventually put up one of the real A-12s on the pole as well, but the first one was just a mock-up. The one that you saw was upside down. But it became a test, to us, it was a test engine or test bed for technology. And we were applying what we could learn from that plane to future technology in the stealth field, which became the F-117 and the B-2 bomber and some of those that followed out there. But this was the very early days of the stealth, and that was the advantage that we saw in Archcart, besides what it did, the good it did us in North Vietnam, was how it advanced the stealth technology that we could apply into modern aircraft that we got today. Okay. Any questions?
Yeah, a couple questions for TD before we move on to Roger Andersen.
I would love to ask you why you had to bend upside down to take a cross section.
We just wanted to see that. We looked at it from all angles, but it was so bulky we couldn't really pivot it. The pylon that we used, it was like in a car garage where you raise the car up and down. It was hydraulic, but we couldn't. But the plane was so big we couldn't rotate it. A lot of the planes we could rotate the angle, would circle them where we could actually. We're looking at them with all these radar, every radar known. We're looking at it with them, and we're plotting it out on charts so that you could see what part of the plane is reflecting back to the radar. And for example, with some of our early stealth, we kept fine-tuning. We'd look at them, they'd take them back to the factory and work on them 2 or 3 months, then bring them back out, we'd put them on the pole and look at it again. And we got the Have Blue prototype down where we'd have to stick a pin in it to get a reflection for a reference part, so we'd know what part of the plane was looking at. We got it down to where a bird landed on it. We'd see more of the bird than we saw the plane. The pole itself became, the background noise of the pole became an interference. It was stronger than the plane, so we took a big cube of styrofoam and whittled it down into a circle, and we'd put the prototype on styrofoam. And we got it down to where the helmet of the pilot, we could see it, but couldn't see the plane. And then we even got it down to where the rim of his glasses would give more of a reflection than the plane itself. That's how much we advanced into the stealth. But it was a learning process, but it all started with the A-12.
At that time, during your career, were you working on the harmonic radars?
No, I was in Army Intelligence when I was in Korea. And what they did is put me up on the observation post to tell them what the enemy was doing, so they shoot artillery at it. I had a life expectancy of about 30 seconds.
Sir.
Hi. As a kid growing up in Indian Springs, I got to see some of what went on, so I appreciate what you did. A comedy thing, I understood that you painted designs on the desert floor to throw off the Russian satellites as they flew over. What were some of the funnier things you saw?
We did all kind of fun and games for the Soviets. I'm sure they did the same thing. And I'll start before that, your question. In Kadena, when we was flying, we had 3 planes that we dispatched from Groom Lake to Kadena, and along with the pilots, and they rotated back and forth, and our main base was still remained at Groom Lake. But the Russians had a trawler sitting right off the coast of Korea, and every time one of our planes take off, they'd radio ahead to warn the enemy, here they come. But we would change, so we didn't want them to know how many planes we had, so every plane that took off had a different tail number and a little bit of different paint scheme. So that's what the games we played in Kadena. But out at the area, particularly when we got the MiGs, that's when we really stirred the Russians up, and they really knew we were out there, and they started trying to monitor what we were doing, why we were doing it, and this sort of thing. And they would launch satellites. This was not too many years after Sputnik, which was the first satellite. But they could get about 4 to 5 satellites over eventually a day. but we knew what kind they were, and to play games with them, if it was their infrared, which we knew what type it was, we would draw a shape of some kind of exotic plane out on the tarmac, and then just as satellites coming over, we put a couple of shop heaters in the rear of it, like the engine, and like to give it a heat signature to make them think that we had something crazy out there. And, so they took, well, it cost them a lot of money to figure out what we had out there, because they just, what the world they got out there now, you know, sort of thing.
Okay.
Did you ever hear back that they actually notified somebody they saw that?
Yeah, we drove them crazy with it. They spent a lot of money and a lot of assets, and it actually beefed up the security of the area. And I can say this, it's been declassified, but we ended up having the whole squadron of MiGs. That's what we learned on the MiG program became Top Gun and Red Flag. We learned that it took 10 missions in the combat zone for a pilot to learn how to fight the enemy enough that he might survive the war. And that's what some of the things that we learned out of these projects when we went into the tactical phase of it. So we decided to give these pilots those 10 missions here in the desert of Nevada rather than in the war zone. So we actually acquired more MiGs, different ways. I won't go into all that, but we had a whole squadron out there. But we didn't. The Soviets was very interested in that because they knew we were gathering these things up from different places, Indonesia, different places, and so they were bombarding the area out there to try to determine how many MiGs we had. So we merely moved the MiGs to Tonopah and had them looking over here, and we're flying over here. And so that's some of the things we did, because they did draw attention to them. So we went out of our way to draw their attention. If we really had something hot we didn't want them to see, we'd put it over here, and then we'd say, hey, here we are, guys, and make them come in to waste their assets on us.
Was that you, the lead comment?
Did what?
Was that you, the lead comment? Thanks for everything.
You bet.
Thanks, TD. Roger?
Good evening, ladies and gentlemen, and you know, as I listen to TD and Frank tell you their functions up at Area 51, and I marvel at this because, you know, a few years back we couldn't say anything about this at all. And it was kind of difficult because we had families that lived here in Las Vegas. And we went to work every Monday, came home usually on Friday. And it was a whole different situation for an awful lot of years, and we signed some paperwork and made some pledges that we would never say anything to anybody until it was declassified. And finally it was, and that was a good day, I think, for all of us, and for all of you too, so you can kind of understand some of where your tax dollar goes and what it does in protecting this country. My job at Area 51 was basically working in a command post. I flew some support aircraft in support of the mission, but basically I was there to work in a command post and coordinate things with the FAA and with the refueling. We had a KC-135 unit up at Beale Air Force Base, and we had to coordinate all those refuelings and set that up with the FAA and make sure that everything went smoothly. That was an interesting job and a challenge, and of course it was a big challenge when we took 3 aircraft and moved them over to Okinawa at Kadena Air Base. And we had to set up a command post over there, and that was my responsibility as well, and a challenge. And that same command post then, of course, went right over to the SR-71 group when they picked up the requirement over there after our program went away. I think that I know that I often wondered why I ended up at this job up at Area 51, and I know my family wondered about that too, and I'm sure that these gentlemen had the same experience. And you can't really, pardon me?
We're wondering too.
Yeah. And it was just something you couldn't speak about, and the families understood that. And I recall when I went down to the Washington, D.C. area to be looked at for the job, and of course I asked them what it was about, and they wouldn't say anything about that at all. And we went through some pretty extensive testing, and I went back home. I was stationed up at McGuire Air Force Base in New Jersey at that time with a refueling squadron. And I waited for about 6 months, and finally I get a call from them, and they say, well, you passed the test, and are you ready to go to work? And I said, sure. Well, I'll be going to work. Well, we can't tell you that right now. And so, you know, you're kind of stuck with the task of going home and telling your wife and 3 young sons that you don't really know where you're going to go, but are you ready to go with me? And they finally said, well, you're going to be west of the Mississippi, which I think one of my kids said, could that be all the way to the east side of the Mississippi? So, you know, you have to get through these things, and suddenly, you know, I had orders to come out here to Las Vegas and to report into a trailer park on the Boulder Highway. I'd never seen an assignment like that, and we did, of course, and they had a trailer all outfitted with food and everything, and within a week, I was picked up and taken up to the area. And on the way, it was one of the fellows that I had met, Hank Nerge, if you recall. Picked me up and took me up to the area. And on the way, I said, well, what's this all about? And he said, well, you'll see. And of course, a couple of hours later, we arrived up at the area. And then you have an opportunity to they open up the hangar doors, and you see the aircraft that you're going to be working with, like nothing I'd ever seen. And my first impression was, and Frank, don't be hurt by this, but I felt it looked like a hydroplane, something that would, you know, be on the water and go really fast. That's what it looked like to me. But there were some cans hanging on the bottom of it, catching fuel, I found out later. So, you know, there were just a lot of different things that come to mind when you think about a task like this. I was up at the area from 1965 to 1968. Taking the 3 aircraft to Okinawa was maybe the highlight, and the ox cart part of our mission that was really exciting. We had a lot of things, a lot of interesting missions stateside. I'm trying to remember, Frank, I think the most refuelings anyone experienced was 3 in any flight. Is that correct? I think
Yeah, 3. Lots of 3s.
Yeah.
Top up and drop off in 2. And we did some tests that were designed to see how long the legs would go, how long the cryogenics were lasting.
Mm-hmm.
You know, we carried a lot of things other than fuel. We had a lot of exotic liquid nitrogen, liquid helium, and they were for various systems. And we wanted to see what their practical life was. So I think the factory did the flying, not us. Lockheed did some missions up there in that test area.
Yeah, that's best.
Well, Bill Park flew that 10,000 mile thing, you know. And that had more refuelings in it than that. So I think 4 and more maybe, but mostly for test, not operational.
Okay. You know, these fellows gave you an awful lot of information, and Dr. Robarge really he knows this program so well, he knows it better than I do, and I was there, so he's done a great deal of research from all aspects, and I think we've answered most questions, but I would be happy to entertain any questions you might have.
Yeah, I think we have time for one from someone who hasn't answered one yet.
How maintenance intensive were the aircraft?
How big what?
How maintenance intensive were the aircraft? How many man hours of maintenance were required versus the flight hours?
I'm going to have to ask Frank to pick that one up. Do you have a feel for that?
They had a cast of people out there who did that. I don't know. You could turn an airplane around in a day, You could do that. You could fly it in 3 or 4 or 5 hours and turn it around and go the next day if there wasn't any major squawks on it. So I don't think it was terrible unless you had problems with inlet. If you had unstart problems, those required a lot of messing around, and they had to look at the recorders. We had inlet recorders, that were on the airplane, the dictate system, and it would record parameters and maybe show what was going on at the time of one. Those would cause that was hairy, and it took maybe several days to fix that. But a quick turn on an easy airplane with no great problems, you fly it the next day, easy. With a crew, probably, let me think, there's probably a crew of about 10 guys working the airplane. So I don't ever think I've tried to break it down in maintenance man hours per flying hour of the airplane, but if it didn't have a severe problem, it was no different than any other fairly complex airplane.
Okay. All right, I'm afraid that's all the time we have for the main event, and thank you so much for sharing your thoughts, gentlemen.